Hello my dear learners, welcome to my video lecture on robot technology. This is the third video lecture on the robot technology series, and today in this session I will be covering physical configurations of a robot. In my previous video lecture I had talked about the robot anatomy, the joints and links of a robot. So moving on forward, by understanding the robot joints and the links, today we will understand physical configuration which understands or which gives the knowledge about how exactly the configuration of a robot works. How should it be? How should you configure the robot so that it moves according to your instructions? So this video lecture is presented by me, Shamant, working at Global Academy of Technology as an assistant professor. So let us begin today's lecture. Robot configuration. So why is that it is very important for you all to know about robot configuration? First of all, let us talk about configuration. What do you understand by a configuration? What is configure? Why do you want to configure it? Configuration, it is actually a noun which talks about the arrangement of parts or elements in a particular form. The robot has to be arranged in a particular form. You have understood about joints and links. After understanding the joints and links, how do you arrange it so that you can build a robot for your own application? That is what it understands or it talks about. So robot configuration specifies the possible movements provided by different robots. So there are different robots used for different applications. There are defense application, there is application for domestic purposes, there is industrial robots. So you have configuration for different purposes. So how is that possible movement provided? The majority of present commercially available robots possess one of these four basic configurations that we are discussing today. What are they? They are polar configuration robot, cylindrical configuration robot, Cartesian configuration robot and jointed arm configuration robot. So it is all about the configuration, the way you are fixing the joints and links together, that constitutes to these configuration of a robot. We'll see one by one what are these configuration of a robot and how exactly the robot works for that particular configuration. So the first type of robot is a polar configuration robot. A polar configuration robot uses a telescopic arm that can be raised or lowered about a horizontal joint. So here we are talking about the telescopic arm. So what is the function of the telescopic arm? This telescopic arm gives the flexibility of for the robot to move its hand or the end effector to the forward or in a forward direction, so that it can reach the maximum point or the farthest point by moving its arm or end effector forward. This robot consists of one T joint, one L joint and one R joint. What is this speaking about? This is speaking about the joints whatever we understood. What is T joint? T joint is nothing but twist joint. So generally in all the robots you can find the twist joint at the base of the robot, so that it gives the flexibility for a robot to rotate 360 degree. That is the importance of a twist joint. Then it constitutes one L joint. What do you understand by L joint? L joint is nothing but a linear joint that we discussed. That is the first type of joint. So linear joint provides the flexibility for a robot to move its arm in a forward direction and then retract back in the same direction but in a opposite way. Then what do you understand by R joint? R joint is nothing but a rotational joint which helps or which gives the flexibility to rotate in the axis of the input link. So hence this particular robot, that is polar configuration robot, is also called as TLR configuration robot. The name coming from the joints it possesses, that is one twist joint, one linear joint and then one R joint. the workspace. It is very important for you to know the workspace, and the workspace in which it moves is spherical. That is, it can have the work volume and it can reach the points in a spherical shape. That is what it understands. Workspace is nothing but it is the space in which it can move and execute its operation. So that is about the polar configuration robot. So here you can see the images which are related to the polar configuration robot. You have two images which is depicting a robot. One is a 2D figure and the other one is a 3D figure. Now, as we understood, the polar configuration robot consists of three joints. One is T joint, that is a twist joint, which is named as T, and then one is linear joint, which is named as L, and then one as rotational joint, which is named as R. So generally I told you the twist joint is at the base. So this is the base, and it makes all the other parts which is mounted on the base to be moved or to be rotated around the axis of the base 360 degree. So here it can rotate. That is why the T is depicted here. And then one L joint. What is L joint? It is a linear joint. So as we discussed that it has a telescopic arm which can move forward and then it retract backwards. So that is given by the L joint, that is linear joint. And then R joint. R joint is rotation. So this arm assembly, the entire arm assembly here can be rotated around the axis, that is here R joint, wherever the joint is present, and it can move up and down. Here you can see a robot which is performing the welding operation. It is retracting its arm and then it is moving its telescopic arm forward and adjusting itself to the contours of the process that it has to do. So here when you have a contour surface and there the operation has to be performed, then it has to adjust itself so that wherever the robot is mounted, from there itself it can perform the operation. And the work volume talks about the space in which it can execute the operation. So what is the farthest distance that its arm can reach? And then when it is rotated around the axis of the rotational joint, what is the maximum height that it can reach? So that is how the polar configuration robot works. I hope you have understood what is a polar configuration robot. Next, we'll see the cylindrical configuration robot. So cylindrical configuration robot, it consists of a vertical column and a slide which can be moved up or down. As the name itself suggests, cylindrical configuration, it has a work volume which is in the form of a cylinder. So the robot can be moved in a work volume which is similar to a cylinder. That means it can move up and down, and then it can reach to the farthest point at one particular point, and then from a center, say for example, it can reach 10 centimeter. And when you draw a circle of 10 centimeter to a height of 50 centimeter, that will be its work volume. So you can imagine a cylinder, and so wherever the robot is fixed, and from that point it can move around in the workspace of a cylinder. That is what it means. So what does this robot consist of? What joints does it consist of? It consists of one T joint. Obviously, twist joint should be there if a robot has to rotate 360 degree. If it has to rotate 360 degree, twist joint is mandatory. Almost all the robots will have twist joint by default. Some robots, for the specific application, they might have different joints, but generally speaking, if a robot is fixed in one particular place, then it consists of a T joint so that it can get the flexibility of moving around 360 degree. And then one L joint. L joint, again, it is required for retracting or moving its arm forward and then backward. And then one O joint. Here, instead of there in the previous type of configuration robot, we had TLR configuration, that is rotational joint. But here, instead of rotational joint, we have one orthogonal joint. That means the input link is horizontal, whereas the output link is perpendicular to that particular axis. So that is about cylindrical configuration robot. In the next slide, we'll see how exactly the cylindrical configuration robot works. So here there are three images which are shown. One is a robot, the other one is work volume of the cylindrical configuration robot, and the other one is the actual working. First, I'll talk about the robot here. So robot, it consists of what? One twist joint, one L joint, and then one O joint. So twist joint is at the assembly of the arm, wherein the arm assembly can rotate completely 360-degree and it is moving up and down in a column. So there is a column, and the maximum height what a cylindrical robot can move, it depends on what is the height of the column. Say for example, this height of the column is 50 meter and the arm assembly can go up and down through the 50 meter. That is how it is understood. One twist joint, one L joint, and then orthogonal joint. So orthogonal joint is making the arm assembly to move up and down. And as we discussed, the work volume is cylinder. So here you can see the cylindrical work volume. The maximum distance the arm can reach is the locus of the points of the circle here, and the up and down motion what it can get depends on the column of the cylindrical robot. Here you can see the cylindrical robot performing the operation in this small animation video here, wherein it is picking the tubes from the tray and then it is keeping on the weighing scale, and then it is putting back after taking the measurement or the measurement of the weight. So that is about how a work volume or how a cylindrical configuration robot works, and it is used majorly for picking one particular object from one place and then putting it into the other place within the work volume. It cannot go beyond the work volume. This is about cylindrical configuration robot. The next type of configuration robot is a Cartesian configuration robot. A Cartesian configuration robot. So Cartesian coordinates, you all have understood what is a Cartesian coordinates, right? So Cartesian coordinates is nothing but it talks about three axes, that is x, y and z directions. So Cartesian configuration robot consists of three perpendicular slides which are arranged in x, y and z directions. This robot consists of, so here when you're writing in the examination or when you're writing the answer for a Cartesian configuration robot, first write what does it consist of, and after you write what does it consist of, then you talk about the joints. What type of joints does it have? And then the workspace in which it moves. If you write these 3 points, it is more than enough to fetch you good marks. So here Cartesian configuration robot consists of one linear joint, that is to move its arm forward and retract backward, and then two orthogonal joint. It has two orthogonal joint. Hence it is also called as LOO configuration robot, where L talks about the linear joint, O talks about the orthogonal joint, and then another O talks about one more orthogonal joint it has. What is the workspace in which it moves? The workspace in which it moves is a rectangle or a box. You can imagine a rectangle of say 50 as the length and breadth as 25, and then if it has the depth, then that constitutes the workspace of the Cartesian configuration robot. So this is about Cartesian configuration robot. Now we'll understand how exactly the Cartesian configuration robot works. So here again similar images, wherein one image talks about the robot, the other talks about its work volume, the other one is the actual working of the robot. So here one linear joint. What is linear joint? It enables the robot to move its arm forward or backward. Where is that happening? It is happening here. So here in this picture it can retract this arm forward and backward, and then this is orthogonal joint 1. So that this particular joint can be moved in the other direction or other axis. Say for example, if you consider this axis as x, this axis as y, and the bottom axis as z, then in x axis you can find L joint, that is linear joint. In y axis you can find orthogonal joint, and z axis you can find one more orthogonal joint, which is making the arm assembly to be moved up and down. So more clarity you can get here in the work volume. So this arm here is in z direction, which is having a linear joint which is enabling the arm to move up and down, and then you have x and y axis here, wherein there are two orthogonal joint which is making the robot to be moved in x and y direction. More clarity in actual working, you can just see here the x and y it is actually moving in XY direction. Z direction is not shown here, but the Z direction is in the depth space, whatever it has. So this is about Cartesian configuration robot. I hope you have understood the Cartesian configuration robot. The next type of robot that we will be discussing is the jointed arm configuration robot. So this type of robots are actually most popular among the industry people, or in the industries that robots are used, just because it almost resembles the human shoulder and the arm assembly. Okay, so jointed arm configuration robot consists of two straight components that corresponds to human forearm and the upper arm. So that is why this particular configuration robot is actually used widely, because it can perform any operation which is done similar by a human being. So that is why this configuration robot is called as human forearm, and then that is jointed arm configuration robot. So what does it consist of? It consists of one T joint. What is a T joint? It is a twist joint. Okay, in Cartesian configuration robot, we will not see twist joint because it is a specific application robot. Okay, it is a specific configuration. So we can only find LOO configuration, that is one linear and two orthogonal joint. Whereas coming to jointed arm configuration, say for example, you want to rotate 360 degree, then you should have a twist joint, and then two R joints. R joint is nothing but rotational joint. This rotational joint gives the flexibility to move its arm at certain angle, but not completely 360 degree. Okay, it has some constraint. Hence, it is called as TRR configuration robot. Here, the workspace in which it moves is something irregular. That shape cannot be defined. That is why they have given as irregular shaped. We will see how exactly the configuration of a robot is in the next slide. So here you can see the robot. It is a jointed arm configuration robot. You can see the shoulder and the upper arm, and then the base, which has a twist joint. So base has a twist joint T joint, and then here at this particular point you can see the R joint, and here there is one more joint. So two joints are present, which gives the flexibility to move in a similar manner as the human arm and shoulder can be moved. So this is the work volume. This image is speaking about the work volume of the robot, that is jointed arm configuration robot. Here the workspace is somewhat irregular, and that is why you can say that the workspace is irregular. So the actual working of the robot is shown here. The similar kind of jointed arm configuration robot, wherein the parts on the conveyor is picked up and then it is put into the different location. So here you have one joint, that is R joint, and here one more joint, and this is an end effector which is used to pick the parts. And at the base you can find twist joint, wherein it can enable the robot to move 360 degree. So this is how a jointed arm configuration robot works. So these are the four important configurations of a robot what all the robots have. Moving on forward, there is one more robot which is slight modification of the jointed arm configuration robot, and that robot is called as a SCARA robot. The SCARA term is an acronym for Selective Compliant Assembly Robot Arm. Selective Compliant Assembly Robot Arm, SCARA. So that is why it is called as SCARA robot. This robot consists of one T joint. What is T joint? Twist joint, wherein it can enable the robot to move 360 degree, and then one R joint. R joint is rotational joint, and then one V joint. Here you are seeing one joint which was not discussed in the previous configuration, that is V joint is revolute joint. So revolute joint gives the flexibility to move the end effector in a particular or perpendicular to the axis of the input link. Hence, it is also called as TRV configuration robot. And what is the workspace? The workspace in which it moves is in the shape of a bean. You might have seen a bean, how exactly it resembles. The same kind of work volume even this type of robot resembles. So here you can see the images and the animation which is showing how the SCARA robot actually works. You can see a base. The robot has to be installed in a particular location. It has a column, and you have one joint here which is attached to an arm or one particular link. This is a link, which is attached to the column. Here the link 1 cannot be moved up and down. Okay, it is stationary, it is fixed at the top end of the column, and here it contains the rotational joint. And then here joint number 2 is a revolute joint which moves the end effector in the axis which is perpendicular to the input link. And then end effector, here linear joint, you can move the end effector up and down. So this is a 3D image of the SCARA robot, and I told you the shape of the workspace is in the form of a bean. You can also imagine your kidney. So in the form of a kidney, it has its work volume. Here there are two robots which is similar, which has the configuration that is SCARA robot, which has the configuration of TRV, and it is performing the operation. One robot is picking the parts from the circular conveyor and putting it onto the straight conveyor, and then there is one more robot which is picking the parts from the conveyor and then putting it onto a bin wherein it is stored. So this is the application of the SCARA robot. Most widely used nowadays because of the flexibility that it can give, and it can move much more faster, and the accuracy what the SCARA robot gives is very good. So that is why the SCARA robot is predominantly used nowadays in all the industries. So this is all about the configuration of robots. We have discussed briefly about all the configuration of robot, starting from the polar configuration robot, and then cylindrical configuration robot, and then Cartesian configuration robot, and then jointed arm configuration robot, and an upgradation of the jointed arm configuration robot. We studied about the SCARA robot. So these are all the important configuration that almost all the industry prefer, because it cannot go beyond the configuration of these type of joints, cannot go beyond this, because this is the majorly used configuration. If at all it goes beyond, then that robot has to be designed for a specific purpose or a special purpose. So this is all about in today's session. Thanks for watching, and if you are new to this channel, do subscribe my YouTube channel Inquisitive. Thank you for watching.